Hey everyone, this is Chris Bennett, the Blockchain Beard Guy. I want to do a short video series this week and show everyone a sample Hyperledger application. I did this last month for Ethereum. If you might remember, I did a three-part series last month showing you guys a sample elections management platform that was built on Ethereum. Walked you through both the end-user experience and the code base, and I got a lot of feedback from people saying that was really helpful and helped them learn a lot. So I want to do the same thing with Hyperledger. So we're going to go through a few different videos here, and I'm going to show off a sample Hyperledger application that you all can actually get hands-on with at home and play around with yourself. But this very first video, I just want to walk you through some of the basics of Hyperledger, because while a lot of folks are familiar with Ethereum and other public permissionless blockchain platforms, far too few people really understand Hyperledger and private permissioned platforms, and some of the ways that both platforms can coexist and some of the benefits that you get from a private permissioned platform. So quick, a little history. Hyperledger is an open source project that was launched late 2015. Its primary financial corporate backer is IBM, but it is an open source project that is managed by the Linux Foundation. There are over 220 different corporate sponsors of Hyperledger, so it is not an IBM product or offering. It's just an open source project that IBM has contributed a lot to. And unlike its Ethereum cousin, Hyperledger is a private permission blockchain. So that means that all users are named users. We have identity right from the beginning. And knowing who our users are allows us to create permissions and drop role-based access rules. This also means that unlike a platform like Ethereum, things aren't transparent by default. In Ethereum, you can jump onto a site like Etherscan and view the details of any Ethereum transaction made anywhere in the world by anybody. That's not the case in Hyperledger. We don't have that transparency because Hyperledger is really designed for corporate scenarios, B2B scenarios. That doesn't mean that we don't see Hyperledger used for B2C models, and that doesn't mean that we don't see Ethereum used in B2B situations, but Hyperledger tends to focus more on being blockchain for the enterprise. And unlike Ethereum and a lot of other public blockchains, there's no built-in coin or token model. If you want to use a coin or a token, that's something you have to build yourself, and so that's a little bit different than Ethereum and their ERC20 token standards. And again, that's really because it's designed to be a blockchain for business or blockchain for the enterprise. So we see a lot of interest right now with Hyperledger, particularly in supply chain, value chain solution, any kind of solutions where having provenance and tracking the life cycle of an item or good is important, such as food supply chain, manufacturing, etc. So a quick little rundown of the two platforms. A lot of people think that Ethereum and Hyperledger are competitors. They're really vastly different platforms that can coexist remarkably well in many different real-world solutions. But in the Ethereum public permissionless world, we're used to everyone being anonymous or highly anonymous and all data being fully transparent because that data is open to the public. In Hyperledger, again, we have named individual users. We know who all the participants are. And that lets us draw up permissions about who can write and who can read data to the blockchain. And so by default, Hyperledger is going to be closed to the public, and only those people granted access will have access. Hyperledger also introduces a concept of channels, or the idea of having multiple ledgers or multiple blockchains. It's another big difference from Ethereum. On Ethereum, everything lives on one single blockchain or one single ledger. In Hyperledger, you can create multiple ledgers. Ethereum is obviously a much larger network, and the security, the data immutability it provides is derived from that large network size. Hyperledger conducts transactions a little bit differently, as we'll see here in a minute, and so the security in a Hyperledger network is defined by its access control rules. And one of the main differences is in Ethereum, because we have anonymity or a high degree of anonymity, We incent people towards being honest. We incent nodes towards being honest and keeping a good version of the ledger through economic reasons. Miners get to earn a little bit of a reward, hopefully make some profit by helping to keep that ledger in sync and up to date with the right data. In Hyperledger, that economic incentive towards honesty has been switched to a desire to protect one's reputation, because Hyperledger tends to be used in corporate scenarios, in scenarios between businesses, and all individual users are known, then there's a much greater disincentive towards being a bad actor, because we know exactly who you are and your job could be on the line. And finally, I really think that platforms like Ethereum are getting all the attention right now, when really Hyperledger and private permission blockchains are where a lot of growth is going to take place. So a transaction on a public blockchain like Ethereum is fairly simple. A transaction is announced. We might say that Alice wants to pay Bob some Ether. This transaction is then going to be recorded by all miners or nodes on the current version of the block that they're maintaining. These nodes are going to continue to record subsequent transactions until that block is full. And then once the block is full, the entire network is going to stop and compare the contents of their block. And whichever version of the block data is held by a majority of the nodes is then considered to be the truth. And that block is chained or linked to the rest of the previously mined blocks cryptographically. That means anybody can then get in and see the details of this transaction, and the nodes begin filling up a new block worth of transactions. Transactions on a private blockchain are quite a bit different. In a private blockchain, we may have two named users, Alice Johnson of the Acme Corporation and Charlie Smith of Bob's Motor Company. This may be a supplier-manufacturer relationship where Acme is delivering wheels to Bob's Motors. This transaction, the delivery of those wheels, is going to be managed by a smart contract or chain code in Hyperledger terms. The smart contract function is only going to be executed by nodes that are being run by Acme or Bob's Motors. And this is very different from Ethereum, where all nodes on the network simultaneously execute that smart contract function. In Hyperledger, only the participants in a transaction execute the chain code or the smart contract code behind it. And that's very much by design. If you're a supplier in this relationship and you supply Bob's Motors with engine blocks, well, there's no reason for you to get in and help validate the transaction for a wheel delivery. And so as a result, the only transactions that ever get added to a private blockchain are the ones which all the participants have already agreed are valid before the fact. This is much different than Hyperledger. So we know that by the time a transaction has been added onto a Hyperledger blockchain, that transaction is correct, that a majority of the participants have agreed on the accuracy and authenticity of the data, and so that removes any need for further audit. So private blockchains provide some interesting benefits. They still provide us the benefit of consensus. All the participants in a transaction have to agree to the details of it before it's recorded to the blockchain. They give us provenance. We can see the entire life cycle of an asset through a solution like this. We get the same kind of immutability that we're used to in public blockchains. We also get finality. If we have one source where all the participants in a transaction are agreeing to the validity of a transaction before it even gets recorded, well, then we've also created one single source of the truth. And we don't need to go hunting around for the right version of the truth. We know it comes from our blockchain solution. And finally, we get privacy and access control. We can control who the participants are, what data we want to share, what the different participants can do with it, things that we can't easily do in the public blockchain world. So next time we're going to circle back and talk about the different components of a Hyperledger solution, and then we're going to actually go hands-on, and I'm going to show you a real-live Hyperledger solution and point you at all the resources you can use to build one out yourself. So look for the next video coming up tomorrow when we get hands-on with Hyperledger. Until next time, this is Chris Bennett, your Blockchain Beard Guy.